So our webinar today is about bar models and how to use them to solve problems. There's both myself and my colleague Alex, who is our project leader of MathShed, and he'll be talking to you first of all, and then I'll give you a bit of a tour around the MathShed website and show you where you can find different features. But we'll just wait another few moments just for more people to join. So if you've got any questions as Alex goes through the PowerPoint, if you just pop them on either the chat or the Q&A icon at the bottom, I'll make sure that I answer any as we go along if you have questions. Or if you have any questions afterwards, we'll also have some time then to answer any. This is recorded, so yes, you will be able to rewatch it. I will put it on our MathShed YouTube channel, which you can access from the MathShed website, but I'll send the link around afterwards if that's helpful.
Okay, shall I start, Karis?
Yeah, brilliant.
Okay, so today's webinar, as Karis has said, is what are bar models and how to use them to solve problems. So let's start. Right, so bar models, they are a feature of this Mastery Singapore three-phase teaching, however you want to refer to it, the concrete pictorial abstract process, something that the Singaporean Ministry of Education have been advocating for since the 1980s, and that's the mainstay of mathematics teaching in Singapore and has been from those times. It's based on the work of the 20th century American educationalist Jerome Bruner, who devised this three-part lesson process in the late 1960s. He had some books that came out in 66 and 67 that pushed for this type of process, which we covered in the previous webinar that we did, which can be found on our YouTube channel. And essentially, because there's been this logical and stable form of process of education in Singapore for so many years, they have done really well in their mathematics performance for a number of years. And at the same time, the UK, Canada, North America, industrialized Western nations, let's say, have continued to slip down the PISA international rankings, and therefore looked to Singapore for inspiration. And obviously, in recent years, we've begun to see this process being promoted by various different organisations in the UK, such as the NCETM, being the principal organisation that's the real advocate for that in this country. So a little bit more just to recap on the CPA approach for those who weren't in the last webinar. So we know it as concrete pictorial abstract. When Bruner first developed the process, he referred to it as an active representation. So kids making actions with physical objects, iconic representations, drawing icons to represent those objects, and then symbolic representation, symbols like numbers, addition, multiplication, subtraction, equals, greater than, less than symbols. That's the symbolic representation. And then he also developed the theory of scaffolding, which is a term that we all know is, supports that we provide for children to help them access learning that's then pulled away as they become more proficient and masterful in that area of learning. So all of these terms that are really quite familiar to us, the CPA and scaffolding, are from Bruner's work in the late 60s, that was particularly developed in Singapore. But again, we've been using the term scaffolding and have an understanding of what that means in the UK. We've been using it for a long time. Essentially, bar models are one of the key structures in early mathematics, primary mathematics, some secondary mathematics, for that middle phase, the iconic representation. And essentially that is a foundational turning point with children learning new concepts, because it takes them out of the purely physical and concrete before entering the purely abstract. And quite a lot of the learning and conceptualization takes place in that phase. And something that I alluded to in the previous webinar, I'll show hopefully a little more today, is that with bar models, it isn't something that bar models have to be purely pictorial. You can have this kind of crossover and quite a long period of that three-phase process, where you can start with a sort of a concrete pictorial blended moment into a more traditionally purely pictorial moment of learning, and then into that moment where you do have the bar model, but then those abstract number sentences are being written next to those bar model jotting. So hopefully I'll be able to show that. Bar models, we should introduce them as early as we can with children, so that it becomes they become structures and processes that children become fluent in and familiar with. So here we have rather rudimentary word problem. If Jamal has 3 apples and Ruth has 2 apples, how many apples do they have altogether? So we could have 2 children in the classroom and actual physical apples. Or we could do, as I have done, and show them with representations of apples. So here you see Jamal has 3 and Ruth has 2. And then to kind of progress towards a more abstract representation, we can then begin to show the bar model. So here we don't know what the total is, so the total bar has a question mark in it initially, but we do know what 2 of the parts are worth. So here, where we're in this concrete pictorial blended moment, we can place 3 apples and 3 green apples and 2 red apples to represent both Jamal and Ruth's apples, before being able to count, okay, now what's the total? 5 apples. Again, you could be even more at this, that they don't have to be apples or images of apples. We could have 3 green counters, or 3 green multi-link cubes and 2 red counters or red multi-link cubes, or they could be blue and yellow, depending on the level of abstraction that children are ready for at that time. So here we can see that bar models can be used whilst we're still in that concrete moment. And this could be scaffolding or differentiation with your class, where you look at the children, you see how they're progressing, you say, okay, these kids here, they might need to still have the physical objects with the bar models, and others might be ready to progress to a more abstract representation. So instead of apples or pictures of apples, they could have the counters, or they could be ready to move on to what I'm going to show you on the next slide. So here we've got the same word problem again. And this time I'm going to present it in the way that I think people most often think about bar models, and really the principal use of bar models, which is with numbers in them. So we know one part is 3 and one part is 2, excuse me. So the total will be 5, as we saw on the last slide as well. Now, finally, this is where we can see that you can phase through using bar models and really scaffold well from concrete through pictorial into abstract, because we have the bar model here, but then alongside it, we can also use the abstract number sentence. So 3 and 2, again, is 5. Now, it's not just in Key Stage 1 that we can use bar models with concrete resources. Here, number stacks. If any of you are active on teacher social media, you might have seen some of these videos before. I think that the language used is fantastic, and I think that the resources are wonderfully made.
A bit tricky this time, Jess. I'd like you to try and do 3/5 of 65.
Okay, I'm going to write 65 at the top, and I'm going to split into 5 parts because the denominator is 5. I'm going to make 65 down here. And I'm going to put 5 ones. And then I'm going to share it onto the bar model. I have 1 left and I can't split it. So I'm going to exchange, put it back, and exchange for 10 ones. So now I have 15.
So how many ones are going to go in each section, do you think?
3.
Okay, try it and see.
Okay, 3. 3. 3. 3. And there's 3 left, sorry. And there's 10 left.
Good.
So
And what's the last step?
the question says 3/5, so I'm going to get 3. And then if I add them up together, we've got 10, 20, 30. 1, 2, 3, 4, 5, 6, 7, 8, 9. 39.
39. So 3/5 of 65 is
39.
well done. A bit trickier this time, Jess.
Okay, so here we're looking at a child working on fractions of amounts, and still you can use concrete resources with the pictorial representation of the bar model to great effect. So a point I really feel is quite worth making, something that I struggled with as well when I first started using bar models in my classes, is that really you want to be using plain paper rather than squared or grid paper to draw bar models. And the reason for that is that you want something that is going to be like really quick for kids to do jottings for, where you can have a stable whole amount, and then not have to fuss, like have kids going, right, if I'm using my squared grid paper, I've kind of got an idea that I've got 3 parts that are bigger than 2 of the other parts. So I need to make sure that my bar model, the total bar, is like 13 squares wide. So I've got 3 lots of 3 squares and then 2 of 2 squares. If they're doing that, they're doing so much thinking that isn't being applied to the problem. Whereas if they have a piece of plain paper, be it an exercise book, a worksheet, or even a piece of scrap paper, it's going to be so much faster. And really, that's what we want. We don't want to be holding the kids back and having them with all this unnecessary cognitive overload, trying to figure something out that really doesn't help out. And another point here is that you want children to not, develop a misconception, as in this middle example here, where they begin to think that a 5th is larger or the same size as a third, that 5/5 are more than 3/3, because they're not. And I mean, this is something that I do worry about when I see people using Numicon for equivalent fractions, or really most kinds of fractions work, because this is another thing that would cause an issue really for fractions. And also we'll see a lot of the examples I'm going to show as we go on now, like fractions of amounts, percentages. Quite a lot of bar modeling is based in this sort of fractional thinking, let's say. So really we want to have a constant width, let's say, of a total bar, such that children have this conception that one whole is one whole, and parts of wholes can be different sizes, and sometimes they're the same. So you have 4 lots of 3, let's say. So there'll be 4 parts, each with 3 in them, and the whole will be the same size. It's only when we're making a comparison where we know one thing is bigger than another that the larger number should have a larger bar and the smaller number should have a smaller bar. So that's one thing. If there's one takeaway from this today, I hope it's that plain paper is the way forward rather than squared or grid paper for drawing bar models. Okay, so another thing is some schools and different textbooks and so on and so forth have different types of bar models that they use. What I would say is there's value in having a fixed policy such that it's the same as having common language in maths lessons, like sentence stems and children using the word subtract for taking away, and negative rather than minus for a negative number. That makes sense. But then also them being able to use minus for subtraction or for a negative number. That's a separate example. But the point here is that it's good for children to have one set of bar models that they're used to using, but there's equally strength in them being shown bar models of different kinds, such that they have a flexibility in their own practice that they can, if they're presented with a bar model, in the SATs, for example, that's different to the ones that you generally use in school, because you don't know what sort of bar models or bar model derived representations are going to crop up. If the children are used to that varied practice, then I think it serves them better, gives them more mental models to work with. But at the same time, it is necessary for them to have a base to work from. So talking about that, here's 2 different ways of representing a subtraction problem. So if Ahmed and Eve have 8 oranges in total and Ahmed has 5 oranges, how many oranges does Eve have? So here on the left, we have a part whole bar model, and on the other side, we have a comparison bar model. And clearly, both work. Some traditionalists would say that we should really only use the right-hand bar model because it's a difference problem, and you want to be able to represent that difference with the curly bracket. But if children have both at their disposal, and for whatever reason they're more accustomed to using one than the other, if they get to the same solution and they're able to describe why and how they got to that solution, that's great, for me at least. So here you may have seen a version of this flowchart elsewhere. We have our version of it. And here I've referred back to Rucksack, which many of us may know, some of us might not be so aware of. It's an acronym: read, underline keywords, choose an operation or operations that you need to use, solve the problem, write your answer, and check your answer. And people have decried Rucksack as meaningless and pointless and useless and all these sorts of things. Who knows? But what I would say is that this bar modeling flowchart really helps contextualize and make Rucksack useful, because here children know how to understand, because we've got these concepts of needing to combine, needing to separate, missing parts, you know, choosing the keywords. We've got all these keywords along the bottom, altogether, total, per, share, difference, equally, times, so on and so forth. So that helps them choose the key words and choose the, underline the keywords, choose the operations, which will then lead them to solve and answer and check. So I think that this is a really handy resource. We have it as a free download on our website that we can point you towards. Yeah, so that I think that's a handy takeaway as well, I hope. Okay, so we can use bar models for all of the 4 operations and many other things. So I just thought I would go through a few examples. So here, relatively standard word problem, something we might encounter in lower key stage 2. James has 237 tokens. Yasmin has 342 tokens. In total, how many tokens do the 2 friends have? There is a typo there that I will fix afterwards. So here, as in the flowchart, we have parts, we do not have the whole. So, and the parts are different. So we know this is an addition problem. So we've got 2 parts here that are differently sized. And then we're going to have a question mark in the total bar. Add it together, we get 579, which we can represent in the abstract number sentence, but we can also show here, because there are no exchanges in that addition problem. Hopefully children can do that mentally. Here, too, we can use bar models for subtraction. Ahmed has to walk 453 meters to get to school. Eve has to walk 689 meters to get to school. What is the difference between the 2 friends' walks to school? So again, we can use the part, whole bars with the missing part, or we can use the comparison bar to solve this. Either way, we're going to get 236 meters, which is the answer. We can use bar models for multiplication. So again, we would think back to the flow chart. We'd be reading Farmer Sam has 4 cows. We know there are 4 cows. On average, each cow weighs 360 kilograms. So we know there are 4 parts. And we know that each part should be 360 kilograms. How much do the cows weigh combined? So we can draw a bar like this. We've got 4 parts with 360 in. Now we need to find the total. Do calculation, and it's 1,440 kilograms. Division. Again, we would think through that process. The flow chart, Farmer Sam has 6 rams that are all the same weight. So we know there are 6 things and that they are equal. So because they're equal, it's going to be a division word problem to solve. In total, the 6 rams weigh 672 kilograms. How much does 1 ram weigh? So we'd have a bar model like this. We have a total bar of 672 kilograms in, 6 empty part bars that are of equal size. So we know then it's going to be 672 divided by 6, and we get 112 kilograms. And that is our answer. Now, this is very similar to what we saw in the number stacks video. We can use bar models for fractions of amounts. Here we've got 2 steps. We're going to be dividing and then multiplying the part amount that we find. So James had 355 marbles at the beginning of the year. By the end of the year, he has 2/5 of his marbles left. Sounds like James is a teacher, maybe. How many marbles has James lost? He really must be a teacher if he's losing his marbles by the end of the year. Right, so we've got 355 marbles at the beginning of the year. To find fifths, we obviously have to divide by 5. 355 divided by 5 is 71. So we put 71 in each of the equal 5 part bars. But then we need to find 3/5, the total number of marbles that James has lost. 71 times 3 is 243. I do think I've messed up there. I think it's 213. But the point remains the same, that we can use bar models for fractions of amounts. We divide first and then multiply. We can use the same bar model that we would use for division. And then if we use this curly brackets, or equally, you could then use a second bar model where you'd have 371 parts and then an empty total bar, which hopefully you'd be better than me. You wouldn't have lost all your marbles in the run up to a webinar, and you would have put the correct answer, which is 213 marbles lost. Okay, so at full price, a pair of shoes costs £60. The price is reduced by 20% in the summer sale. How much do the shoes cost in the summer sale? So here, it's very similar to the fractional amounts bar modeling, but it just relies on children having that known fact that 20% is the same as a fifth. So that's the wonderful thing about bar models, is that it kind of takes away from some of that cognitive load. It helps children to have a familiar jotting that isn't initially so number heavy, so abstract, to then have a solid working base to work from. So they can run at this with, okay, I know the total is £60 and I know that 20% is a fifth. So they would then be able to have their total bar with £60 in it, and then 5 parts, because they know 20% is a fifth, so 5 parts. So each 20% or each fifth is £12. So then it's a matter of figuring out what 4 of those parts is worth. Again, I've drawn the squiggly bracket here, the curly bracket. Could equally have the second bar model for 12 parts and an empty total bar. And then again, children could then either multiply 12 by 4 or take away 12 from 60. And the answer is these shoes are going to cost £48 in the sale. Another wonderful thing with bar models is that they are fantastic for algebra. In fact, there's some algebra that kids in primary school who've really gotten well with algebra can use bar models to solve algebraic problems that fairly advanced mathematical adults sort of have. They're like scratching their heads and are trying to pull off quadratic equations and all sorts of things to get to it. And if these kids are really proficient in their bar modeling, they'll just be able to sketch it out and have it solved while, you know, dad's gone down the pub with his friends and is still scratching his head to figure it out. Right, so the total we know is 22. We have 2 unknown parts, but we can be pretty confident in the fact that these unknown parts are going to be larger parts than the known part, which is 4, because 4 is only a very small proportion of 22. So that's why that part is smaller, and those 2 other parts are half of what's left, because there's 2 of those, and then there's the 4 that we know about. So then to find out what 2y is worth, we have to take 22 away, 4 away from 22, which is 18. So then we have 18, and we've got a second part bar model here. So now we know that 2y are equal to 18. So y is going to be half of 18, so 18 divided by 2. So know that y is 9. So yeah, there's loads that sort of so many things that we can do with algebra and bar models. I think bar models are fantastic for that. And I think that we're beginning to see a lot of secondary schools using bar modeling or algebra tiles, which are somewhat concrete representations of bar models specifically for algebra. So yeah, wonderful for algebra. They can be used for multi-step problems. Like here, we can see this word problem. It's in 2 parts. So a papaya weighs 700 grams. A watermelon weighs twice as much. What is the weight of the watermelon? So here we've got this comparison bar that's being used really well. You can see in the middle of the screen here. So then clearly it's easier to get to the fact that, right, we know that the watermelon is twice as heavy. So it's going to be 1,400 grams. And altogether, we add it together, and it's going to be 2,100 grams. Bar models can be used for like so many areas of the curriculum. So even here, angles around the point. Who would think you would use bar models for geometry? But they work wonderfully for geometry because we have so many known facts here to work from. So we know that the total angle around a point is 360 degrees. We know that there's an angle that's 227. We know that a right angle is 90 degrees. So we just have to figure out how many more degrees do we need to get us back to 360. So this again is a multi-step problem because it involves one addition calculation and one subtraction calculation. So 227 plus 90 is 317. So then we need to find out the difference. So 360 subtract 317. The missing angle is 43 degrees. And of course, why else would we want to know what bar models are than to use them for SATs papers? So yes, there are plenty of questions in SATs papers that if children have bar models to accompany their more formal abstract number sentences, it's a great strategy to have. So with this problem here from the Key Stage 1 SATs paper, this is from paper 2, 2019, the last official paper. We know that Ben has 90 pence, so we've got a total amount, and then he buys 2 tickets, which are each 35 pence. How much change does he have essentially? That's the unknown. This isn't really much different to the algebra question really, which is quite interesting. And here, 2 lots of 35p, 70p. So from the 90p, we take away 70p, and we know that Ben has 20p of change left over in his pocket. Okay, and this one from the Key Stage 2 SAT. So this is paper 3, 2017, but the Key Stage 2 paper, all of them are littered with questions that you could really use bar modeling for. And there are some representations of like equivalent fractions that are area model diagrams that are a derivative, I would say, of bar models that are already in the paper. So that's what I say, like having that varied practice and varied representation of different kinds of bar models, it really comes in handy for Key Stage 2 SATs papers in particular. Right, so 3 pineapples cost the same as 2 mangoes. 1 mango costs £1.35. How much does 1 pineapple cost? Okay, so we know 2 is the same as 3. So 2 mangoes is equal to 3 pineapples. Got £1.35 for each of the 2 mangoes. So the total amount, which we still don't quite know yet, we find by multiplying £1.35 by 2, which is £2.70. And then we know that there's going to be 3 pineapples to make up £2.70. So each one, we divide £2.70 by 3, and we know that each pineapple costs 90 pence. Okay, so another resource that we provide, which hopefully makes bar modeling a little friendlier and more fun, is our Advent Callum bar. I wonder where we got the idea from. Who knows? And it's something to kind of carry on the bar modeling once you've got the kids kind of geared up to it throughout the autumn term after the summer holidays, something to finish off the term with. So yeah, these are free. The whole thing. There's 4 bar modeling challenges per day for or up until like Christmas Eve in December. I mean, don't feel like you have to send the kids home and be doing this on Christmas Eve, for goodness sake. But yeah, it is available there. And essentially, we also need to take these and adapt them and make a similar version that is less seasonal, so that this can be practiced throughout the year. And that is on our radar, and we will get round to it. But yeah, in the meantime, these are here. If it's Christmas every day in your classroom, feel free to use them throughout the year. I'm sure there's someone who loves Christmas enough to do that. Yeah, and I will now hand over to Karis. So thank you very much for listening.
Oh, there we go. Thanks so much for that. What I will do now is share my screen and show you MathShed and the website part of things. Right, okay. Okay, so you might already have some of our subscriptions, but this is what the Teacher Hub looks like. And here you have got all the resources. I'll just very quickly show you what you get with MathShed. So it follows the White Rose progression of the curriculum, and we've got resources from reception to year 6. Stages are the same as year groups here. You can see our Advent calendar as well down the bottom. So if I click into year 2, in year 2 and year 6, we also have a SAT practice area with past papers, and we have the exact same version with year 6 too. So if you want that, that's really good. You can also assign these for pupils to be able to complete on their login if you want to set them as home learning. So they're the exact same style questions from previous SATs papers, but just we've altered them a little bit to make them ours. But they'll then get used to the wordings and the layouts. So if we have a look at a specific lesson, so you can see when you click into a term, you then get the blocks. If we click on block 3, and then we can see we've got the different lessons here. We also at the bottom have our end of block assessment, which you can either print out or set for pupils to complete on their logins. And with each lesson, if we look at lesson 2, we have 3 different types of resources. So this is for every lesson from year 1 to year 6, we'll have these. So we have resources, which are the teaching PowerPoints. We have question sets, which are the quizzes, which you can set the pupils. And we also have lessons, which are a mixture of question sets, as well as recorded teacher talk time. So some of these are by myself and our other colleague we're both trained primary school teachers. So I'll show you one of those. And these are really ideal for home learning, consolidation, or also interventions. So if we click on a PowerPoint, first of all, I've got one down here. I'll just need to open that and switch my screen share. There we go. This is what the lessons look like. So they all have the same structure. We have a success criteria, a starter, and then we have teacher talk time through with different activities, which the pupils can complete independently if you wish to. This is one that shows how we use bar modeling throughout, where it's relevant, obviously, and where it will help. Here's how we use it for money in this case. And then what you can do is once you've completed this, they all have an evaluation, so some sort of prove it statement or something that uses their reasoning skills from what they've learned within the lesson. After that, you can then assign the pupils the corresponding quiz. And that looks like this. Let's find that again. So here's what the corresponding quiz will look like. If we play this, we can go through it quickly. It's just logged me out. Let's click on it again. Here we go. There we are. Okay, so you can also generate this as a worksheet if that's easier, or if you have some pupils that don't have devices. If I click play quiz, this is what it will look like if you assign it to a pupil, and this is what the pupil screen will look like. So you can click play, and we have different things such as matching amounts. So they can move these, adding up amounts such as this. Just quickly click through some of these. Things like comparison symbols. So they're using everything that they've learned within the lesson that you've taught them and then practicing it independently. I'm just going to quickly click through some of these. So they've got quite a few different question types, as you can see, to keep them engaged. And again, we've got some different bar models and things like that there.
Which of these amounts could be used to complete the bar model?
And you can also read.
Select an answer below.
Okay, now the third thing that we have for all of the lessons, we have our PowerPoint, we have our quizzes, and we also have our lessons. Now the lessons look slightly different. Oh, I was just going back, there we go. Now our lessons are basically a playlist of video clips and our quizzes. So this is what they look like. And when you assign them to pupils, they are automatically taken through in order. They can't randomly click on anything, but from the teacher overview here, you can see which parts are explainer videos and which parts are activities. So this is all on the same lesson. So if I click start, we can then just have a preview as what it would look like as a pupil. So it will start off with the success criteria. And these are really good as well for interventions. If you have them as a small group with an adult, because you know they're getting exactly what they need that meets that learning objective.
Today we're going to learn how to count money in pence. For this starter, which coin would you most like to receive from the Tooth Fairy? Pause here to explain your answer. Maybe have a chat to the person sitting next to you.
Now I'll come back to the lessons in a moment. We also have our quick maths slides, which are also really useful. And we have these from year 1 to year 6. And we have these for every single week for the school year. And what they are teaching slides with different mental math skills. So these are really good to have them as a habit of doing these every day, whether it's as the children come in, there we go, or maybe it's after assembly, anything like that. So we have them, you can see here, week 1, day 1, and with the answers and everything underneath there for you. So they're just a really nice way to get the children's mental maths really confident, using things that they've learned in class and using them independently and getting them nice and quick, as it underpins everything else that they'll need to learn within class. So we've got those there for you as well with them. And then what we'll look at next is how we can give work to pupils. So we call these assignments, and I've got all of the different subscriptions here because it's my test account. So we also have PhonicShed and SpellingShed. But if we look at MathShed, we can look at what it looks like if we've assigned some work to a pupil. So what we can do is, I've played as a pupil here already. You can see the amount of games played, their assignment status, which changes, the percentage they've got correct, and we can see if they have played or done their homework and how they've got on here. So that's really nice to see. You can also assign the lessons, which I'll touch on in a moment. And we also have a fluency part of MathShed, which I'll also show you. Now, whilst we're looking at data, we have a competence grid, and any quizzes that a pupil answers that's tagged with a specific curriculum area will feed into this grid. So here's my class, if I'm looking at this class 1A, and if I click into maths and whichever year group I am, and then the next subcategory, so number and place value, for example. Now this is my test account, so I've only played a couple of games on different things, but any information here that has been, any quizzes which have been tagged with this objective, all their results will be fed in here. And that shows over the last 5 games. So it shows a nice bit of consistency, and the colours will change, and it's a really nice way to just see various patterns within the class. So the numbers are created, as you can see there, from the accuracy in the last 5 games. So as long as I do 5 games, the more accurate the information. So that's just a really nice way to have a good look at data within your class. Now, if we have a look as a pupil, so if I just click the play game screen, so if you want to take out a free trial, which you can do, and it will stop after 30 days, so you don't have to worry about cancelling it. You can also have a click around. There are various free resources. You can also play on the game screen just to get a bit of a taster of what it's like from a pupil's point of view. Now, you won't have access to everything depending on which subscriptions that you've got, but we'll click into MathShed. And here you can see all of the different quizzes and lessons. Now, if you set work for a pupil, you can set it so they only have access to what you have set them. So don't worry that you can see everything here. Depending on how locked down you want it to be, you can literally just set it so they've just got the teacher's work. The fluency section, which we haven't looked at just yet, has things such as times tables and number bonds. So you can set, as a teacher, an assignment for a single times table if you're going through them, or maybe mixed ones. And they have games such as this, which the pupils can play against the timer at the top. And we have those with number bonds as well, and addition and subtraction, and powers of 10, so timesing by 10, hundreds and thousands. And we also have a multiplication times table check for year 4 as well, which is in that exact same structure that I just showed you then. So going back to lessons, I'm just going to click on one so you can see what they look like, as our last one wasn't as successful as I wanted it to be. Here's one here. Let's have a look. There we go, we can see the video now. So we'll have a teacher talk time.
Hello, and today we're going to learn how to sort objects. For this starter, how many ways can you sort the cubes below into groups? Pause here and have a chat with somebody next to you.
So it explains what they're doing, and then the next one, they'll be doing an activity based on that. So that's our starter. Here's the explainer video for activity 1.
Next, how many ways can you sort the cubes in count?
And then once they've watched that, that will then help them be able to have a go at this skill, which will practice everything that we have just talked about on the teaching video. There's lots of different things. And then as a teacher, from the teacher side, like when we clicked on the assignment screen, you'll be able to see who's done it, how many times they've played it, and the percentage that they have got correct, which is really nice to be able to see. There are lots of other things that can keep the children motivated. You can set little competitions between classes or individuals, whether it's on a particular times table skill, which we call a challenge. You can also see the leagues and see how pupils are doing and do things like giving certificates. This is a shed score, so it's just based on the score within the last 7 days. So it goes up as well as down, so it keeps it nice and current. It means that it's just not those people that play all the time that have got a really large total score that are always at the top. You can see those there. I think that is everything based on the home page and the Teacher Hub side of things. You can split children into groups, as you can see there. You might have them in maths groups, or if you have another one of our subscription, maybe a different type of group, like a spelling group or phonics group. So you can have lots of different subscriptions at once. But if I stop sharing there, I would recommend that you get a free trial so you can have a good click and a look around as well. There's also a deal where you can get 15% off if you sign up for Spelling Shed and MathShed combined too.
Yeah. thanks very much, Karis, for that, and everyone else for showing up. I hope I shared some things and Karis shared some things with you all that is helpful. And if there are any further questions that people haven't been able to ask so far, please drop us a line, support@edshed.com, and we'll get back to you and hopefully speak more with you soon.
Absolutely. Brilliant. Thanks so much for watching. Bye.